We often have this protein narrow focus on foods, right? We've branded beef in protein, we've branded beans in protein, and lentils in protein, and dairy in protein, even though they're vastly different food sources. But we just, because they contain protein, we think of them as sort of a similar category, but actually they're not when we look at the vast array of nutrients that they provide.
Hello, meat folks. Welcome back to the MeatsPad podcast. This is Phil Bass, your humble servant. Francisco's out there making the world a better place for meat enthusiasts, and so I'll be your host today. Today we have Dr. Jerrad Legako from Texas Tech University, as well as Stephan van Vliet from Utah State University. And today we're gonna discuss a topic that is quite interesting in the fact that so often we talk about one thing or the next, but in biology, nothing really works independent of anything else. And so Dr. Legako, Dr. Van Vliet, thanks for joining us. Welcome to the podcast today.
Hello.
Thank you so much for having us.
Yeah. So what I'm mentioning is, and I've been preempted a little bit about this discussion, is something known. You guys are talking about something called the beef matrix. Is that right?
That's correct.
So tell us a little bit about that. What is the beef matrix, and why is it so important for us to better understand?
So the meat matrix or the beef matrix, I think they're interchangeable. I should say, because the meat from one rumen to the next is, somewhat comparable. But if we talk about the beef matrix, we're really talking about the wide number of nutrients and compounds that are found within the food source that all interact with each other, oftentimes in a synergistic way. And a lot of times this information you cannot get from a food nutrition panel. So a nutrition facts panel has about 30 nutrients on there: protein, fat, saturated fat, right? And then a handful of vitamins and minerals. But food sources in their natural state contain probably thousands of biochemicals that are capable of impacting our metabolism and our health. And what you often see in terms of like the matrix is that if you take those, that the sum of the matrix is more than its individual components. If you take zinc out of the food source and you give isolated zinc, the uptake is probably not as good as when it's provided, for instance, in the meat matrix, which is known as the meat factor sometimes.
Well, and Dr. Legako, maybe you can expand on that a little bit. What is, and yes, and forgive me for, I live in the beef world so much that I forget there's other meats out there, right? So, so Dr. Legako, maybe you can just elaborate a little bit about, what are some of those great components that meat and maybe beef also bring to the table with regard to the meat matrix and how that interacts with our nutrition?
Absolutely. And I think just to reiterate some of those points, the matrix, it's just kind of a word as I see it. It's hard to put a definite term towards it, but it's kind of the sum of what we traditionally think of as nutritive components and then non-nutritive, but that's clearly just the way we categorize things. Nutritive, we're traditionally in that area of proteins, amino acids, essential amino acids, which beef and all meats would be high in those and have high bioavailability. And then you have fatty acids, among those, some of the essential fatty acids, and then also some of those that have been maligned, like saturated fat and cholesterol over the years. And so you have kind of this mix of nutrient components, like Stephan mentioned, that appear on the nutrition facts panel. But then we have, additional things like that maybe aren't necessarily always thought about as being critical for energy and for stamina, but certainly iron, zinc, some other micronutrients would play a role in the nutritive side of things. What's really, incredibly interesting to me and many others are those, as they're currently categorized, non-nutritive factors. Maybe something like collagen, where we traditionally don't think about, the hydroxyproline being incredibly important, but from collagen, other interesting peptides may have some other positive benefits that we hadn't thought about prior, to recent years, where traditionally been focused on caloric content, getting those essential amino acids, essential fatty acids, vitamins and minerals. And I think some of the broader techniques that we have now for looking at those other components will be really interesting as it develops over the, kind of the new research in the coming years.
I believe I was reading a little bit about this idea of the meat matrix. That is it true that, and Dr. Van Vliet, you mentioned it's greater than the sum of its parts. Or maybe Dr. Legako, I can't recall, but it's greater than the sum of its parts. And in fact, having meat in the diet will actually enhance other foods that are being consumed. Is that right?
Yeah, that's correct. I mean, there have been, and it's interesting as you note this, because there was a systematic or scoping review that just got published 2 weeks ago that looked at data between the early study was done in 1966 up until all the way to 2021. There was about 40 papers included. And the overwhelming majority found that when you consume meat with, for instance, a plant source of iron or zinc, right? It could be beans and beef, for instance, in a chili, that you actually increase the uptake of zinc and iron from the beans, so from the plant-based meal, when you have meat with it. So when you consume it as part of an omnivorous meal, then yeah, you see the synergy happening where the non-heme iron actually becomes absorbed to a higher degree, which is, we don't fully understand why that's the case. It's sort of this magic meat factor that people refer to it as, but that's something that you often see, and it could be maybe certain amino acids like methionine or cysteine that play a role in that are sometimes lacking in some of these, or I should say, are lower in some of the plant-based foods, right? Like beans and lentils and grains and things like that. So that's one area. But I must say we don't, at this point, don't fully understand why it works or how it works. We just see that it works. And then on the other side of things, you can also see that this synergy, for instance, certain heterocyclic cyclic amines or other compounds for H&E, which we think of as like heat-formed compounds that may be considered detrimental to our health. Also, one of the reasons why WHO has classified red meat as a potential carcinogen. Well, what we actually see is that if we marinate our meat or eat it with plant-based foods, that we can see that we decrease the formation of these advanced glycation end products or lipid end products by like 70, 80%, right? So that way we get the good of the meat and perhaps not sort of the negative. So you see this synergy between meat and then plant foods where you can get the best of both out of it.
I love that term, that magical meat factor. I'm going to go ahead and steal that idea because I think that's meat is magical as far as I'm concerned. You know, we're converting in many cases, especially with beef and other ruminant, we're converting inedible plant material into something that we can consume. And it's interesting too that you mentioned that omnivorous diet. We are omnivores. We can consume meat. We can consume plants, and it's great how nature has designed us in a way that if we combine that, as I mentioned, nothing works, you know, by itself out there. There's always some kind of interaction going on, and if we combine those two things, we can actually enhance our overall nutrient absorbability, intake, what have you. So, very, very cool. So tell us a little bit about maybe what kind of research you guys might be doing in this avenue. So you mentioned that there's some new information out there being published, and then some background stuff that has alluded to the fact that combining meat with other foods in the diet can enhance our overall nutrient absorption and uptake and everything. But tell us a little bit about maybe what you guys might be working on right now to better humanity with the use of meat.
I'll start. my area of research has kind of been more on the quality side, palatability, flavor chemistry, compositional measurement. And I've come into this space of nutrition and the beef matrix really recently, and it's very exciting. And one of the opportunities we had was to actually take some research that was already undergoing, or ongoing is a better term to use, but ongoing research in the area of looking at ground beef compared to plant-based alternatives. And many, including Stephan's been in that space as well. But what we had kind of done up to that point was the traditional measures of fatty acids, flavor contributing compounds, some palatability work was really revealing. And what we're going to be doing in the next 16 to 18 months or so is taking the lipid fraction and adopting an approach referred to as lipidomics. And so it's a broad look at the lipids, their features, the types of triglycerides, not just the individual fatty acids, cholesterol, phospholipids, and really trying to characterize beef as it compares to some of the formulated plant-based products that are out in the market right now. And I think what we already know from some prior work in metabolomics, working with Dr. Brad Kim at Purdue for our metabolomics work, is that the products from a metabolomics standpoint are wildly different. And metabolomics kind of looks more at the aqueous, the water-based metabolites, peptides, sugars, amino acids, and our kind of initial run through that data shows that quite different, and in agreement with some past work. And so what we're hoping to do on this side is characterize the lipids, and then ideally partner with other individuals who are more in that nutrition space to help us interpret what those lipid features really might mean for diet and health, and use that to probably or most likely come up with a new set of questions and research points to go forward from there.
And Stephan, I'll tell the listeners that just prior to us recording, you actually were running back from a research project in working with some participants. But tell us a little bit about what you guys are working on at Utah.
Yeah, that's funny that you mentioned it. The participant just consumed an Impossible Burger about an hour ago.
Oh dear. Oh, yeah. Well, I'll pray for them.
So they're in good health. They're doing well. So now we are running a initial pilot trial, or pilot in the sense that it's a post-meal trial. So we just look at so we did some profiling on plant-based meat alternatives and then beef. As Jerrad pointed out, they're wildly different. So now what we're interested in knowing from research that we did prior and also other groups, when you eat a food source, a lot of these metabolites or compounds from the food source are detectable in the blood and urine for the hours afterwards. Now, knowing that an Impossible Burger and beef are wildly different in terms of their nutritional composition, what if we feed people these foods and we take blood and do similar metabolomics on the food source as we do on the blood of the people? Do we then also see shifts in the nutritional compounds and other bioactive compounds, peptides in the blood? So can we see that these different food sources give a slightly different composition of the blood, of amino acids, of peptides, of sugars, of fatty acids, and various bioactive compounds, like, let's take something like taurine or creatine or anserine, which are amino acid derived compounds that we know that are not found in plant-based meat alternatives, but are found in meat. On the other hand, plant-based meat alternative may have higher amounts of soy isoflavones, in this case, if they're soy-based. Do we see shifts in that in the metabolome? So that's just basically what we're doing in this study, is just initial proof of principle. What are the main biomarkers that distinguish between these sources? And then if we replicate this in a longer term study, what are the biomarkers to look at? And, do we then see what happens if you don't consume taurine or things like that, right? Which are I should say conditionally essential at a younger age, but we do know that especially in older folks, randomized controlled trials suggest that these compounds, creatine, taurine, and serine, are important for our cognitive function. So those are some of the things that we're not per se looking at cognitive function in the study, but this is just a pilot trial that we have going on, and then we'll follow it up with a longer term trial as well.
Well, after your participant recovers from eating that Impossible Burger, we'll and I just, of course, it's important to investigate all these different food sources. But something that I regularly talk about is just how meat is a complete protein, and it's going to have everything that's truly needed for building the body and nourishing the body in the sense of the protein requirements. Whereas plant protein, you can consume a lot of plant protein, but it doesn't necessarily means that it's meeting all of the needs. And maybe you guys could you expand a little bit on that area, and especially for our listeners out there who are, we have a lot of meat processors, small and large, listening, as well as academics. And sometimes we need to be reminded just how great of a food source meat is. And then maybe expand a little bit about what you've already said of how it can enhance the overall dietary intake.
Well, I'll give a brief description of that. I mean, I think the straightforward answer is it's a nutrient dense component, that there's a high return relative to caloric intake. And I think that's what you're kind of getting at, Phil, to find equivalent protein intake, to find the amount of the essential amino acids in the plant-based protein sources is feasible, but it comes at a higher caloric cost. I think there's that balance of, if that's something you're wanting to do and to pull that more complex diet together, it creates some challenges due to the caloric content that comes along with it. The other thing and maybe you guys can help me expand on this, but the proportion of the amino acids is really critical as well. It's not just the protein content. And so generally skeletal muscle is going to align very well with our proportional requirements for amino acids. And so I think there's a lot of efficiency as a result of that in the protein that you do consume in the meat form.
Yeah, no, I can echo those important points that Jerrad made. And certainly we know that plant sources, at least in isolated forms, if it's only beans or only grains, that they're typically lacking either methionine or lysine. So combining grains like rice and beans can certainly be a way to circumvent that. But as Jerrad pointed out, it typically comes at a higher caloric load. Certainly, what we know from plant sources is that combining them and eating more of them, right, can at least provide a similar amount of amino acids. So if you're at that point, if you're just providing enough amino acids, it doesn't matter if it comes from plant or animal sources, but it does come typically at a higher caloric load. I think that could be very feasible for someone in their adulthood, right, early stage of adulthood. But maybe when you're older and you don't consume as much calories anymore, maybe having more bang for your buck in that regard can be good. What I'm also particularly interested in is that, yes, we often have this protein narrow focus on foods, right? We've branded beef in protein, we've branded beans in protein, and lentils in protein, and dairy in protein, even though they're vastly different food sources.
Yeah.
But we just, because they contain protein, we think of them as sort of a similar category, but actually they're not when we look at the vast array of nutrients that they provide. So the nutrients that go beyond protein, right? The micronutrients, zinc, iron, B12, selenium, anserine, creatine, taurine, and cysteamine, 4-hydroxyproline, a whole host of I know complicated words, but nutrients that may only be found in animal source foods, but not in plant source foods, that we know can impact our metabolism and health. So I think it's really critical that we start moving beyond just protein, very important nutrient, but food sources in their natural state, even protein-rich sources, provide hundreds of thousands of other compounds. And in that regard, we can see that there's, I think, synergy to be achieved between plant and animal source some sources or some nutrients only found in animal source foods, some only found in plant source foods. Taken together, I think we can come up with an optimal diet, and certainly within that regard, you might find individuals that lean towards more of an animal-based diet and a plant-based diet, and it may be fine. But on a population-based level, I believe most folks will fall on sort of an omnivorous spectrum and do best on combining both sources.
I love the way that you guys are bringing this about, in that we can't paint with broad strokes like we always do. Protein, yes, protein is important, but protein's not just protein. It is the building blocks of so many things in our body, and those building blocks are those amino acids. If you have, what I like to share in some of my classes is that if you're going to build a house, you can get a whole bunch of material, but if you don't have the nails, it doesn't matter how much wood you have. You still have to have the other things that are going to help make the complete house that you're building. And so that's kind of what we're looking at here, is these essential amino acids, but even more so having all the right components in the right proportion, like Jerrad just mentioned too. The other thing I believe that meat really does bring to the table, and you guys have alluded to this already, in that you're gonna get the essential amino acids, you're gonna get the building blocks of those proteins in the right proportions, but it's at a more efficient means of taking in nutrients, and it tastes good, for crying out loud. Let's not forget that part, right? It tastes good. Nature has designed this nutrient dense material for us so that we want to consume it. And for a good example, just last night I just gave a talk, and at the end had a chance to, all that was left of the dinner was just a little bit of brisket. But you know what? That little bit of beef brisket, it filled me up. It was great. It was satiating. And something about how nature has designed meat, it keeps us, it fills us, and it keeps us full. And that's going to keep us probably from doing all that excess snacking of other nutrients that maybe we don't need a lot of. But ultimately, we can still have in our omnivorous diet, but still being a very efficient and effective food source. So sorry for rambling a little bit there, but I just get kind of excited about this whole idea of, we got to stop painting in broad brush strokes, and we have to look at the whole approach, the holistic approach of meat as a part of a very healthy diet. So kind of, I'd like to start looking at landing this plane a little bit, and maybe you guys can tell us a little bit about your background, how you got to where you are, and what does the future hold for you?
Yeah, I'll start. I'm a meat scientist. I've been in academia for a little while now, and I'm going to continue to do a lot of research, teaching relevant to meat quality and safety, and kind of work with people in those spaces, and I hope to expand and work with other folks in the nutrition field as well as this kind of beef matrix, and ideally carrying forward some of the chemical characterization techniques that I've employed over the years to address flavor and flavor chemistry, and see if those can be a good tool for others that are wanting to look at unique things about beef that may impart unique responses. One of the examples I was going to mention, Phil, before we jump off, is there's a study, again, going back to that whole concept of the beef matrix or meat matrix, and having these other cofactors, if you will, that affect health. There's a study that talks about how beef can actually inhibit expression of myostatin. So you know what myostatin is, and so that is actually something that inhibits muscle growth in simple terms. And so substituting that in with some other protein source, they didn't see an equivalent response. And I just think that there's other things going on, maybe in the metabolomics, whatever omics that we can dig up that contributes to some desirable health outcomes in a lot of cases, and not all proteins are created equal. So that's kind of a space that I'd like to dig into and work with other researchers on in the future.
Well, I definitely want to get Stephan's background here, but that's really interesting that you just mentioned that. In fact, something I was just recently talking about is kind of teaching the body early on in the livestock side of things, teaching the pre-weaned calf that if you have a sufficient amount of energy, that we can actually teach certain cells to become adipocytes, to become fat cells in the right area, by feeding certain nutrients at a certain period of time. Very fun, very cool research, but it almost sounds like that's kind of what you're talking about on the human side, in that if we can teach the body that you have nutrients coming in the form of very complete good proteins, then maybe the body will be prepared later on for growing muscle and being healthy in that regard. Is that kind of where you're leading?
Yeah, kind of, perhaps. And I admit I don't fully understand it, but there's these bioactive compounds, whatever term you want to utilize. There's parallels with fruits and vegetables that, we talk about antioxidant components, and Stephan mentioned creatine and some of these others that are unique to beef that appear to have some unique response or signaling response, like you're saying, outside of just providing the nutrients that we traditionally talked about for many years.
So my background is in human physiology and muscle biology. So early on in my career, I studied a lot of protein metabolism, specifically in the muscle, in response to protein-rich foods. So these were things like beef, dairy, eggs, also plant sources. And we were just studying it mostly after exercise, endurance exercise or resistance exercise. We know that creates an anabolic potential that can then be fulfilled with protein-rich sources. So that's where it sort of started. But what we were seeing early on in our work is that the anabolic response wasn't just predicted by the amino acid composition alone. It was also probably those bioactive compounds, again, that we don't fully understand. But we saw, for instance, whole eggs and egg whites, very similar amino acid composition, but a higher anabolic response in whole eggs. Dairy and beef, also two high quality protein sources. Again, differential responses that we saw there. So it goes beyond the amino acid composition and probably has to do with some with anabolic signaling and things like that from some of these molecules that we find in the matrix. And from there on, I sort of shifted more towards indeed dietary patterns, clinical nutrition trials. So that's really what I'm focused on now. I am particularly interested in two things. One is food metabolomics, so profiling what is in the food beyond what just appears on nutrition facts panels. Then if we feed those foods to people in clinical trials, what are health responses and what does it do to their metabolism? So that's what I've been working on the last several years, really. So performing a lot of randomized controlled clinical nutrition trials. One of the interests also is diet quality, because we did a study, for instance, where we had people consume beef as part of a standard American diet, which in terms of epidemiological associations, meat is often associated with metabolic disease when consumed as part of standard American diets. Then there are some studies to suggest also that when red meat is consumed as part of a healthy diet, these associations become neutral, or they become a lot smaller, suggesting that the background diet in which we consume individual foods should absolutely not be ignored. And it's probably a main factor, right? Eating a piece of meat with as part of a Mediterranean diet, or with some fruits and vegetables on the side, or eating meat through a fast food outlet, probably completely different health responses, right? So that's a study that we did and indeed found different health responses. So I'm also interested in taking a more broader approach rather than these single foods, because the effects of single foods on health are rarely black and white. So that's been a major interest and studies that we're working on over the next few years, understanding the impact of diet quality when we start linking single foods to human health.
Well, I'll say it one more time. We can't paint with broad strokes. We have to figure out that it's an interaction. It's there's a lot more to it than just the one individual thing that you may be consuming or that you're interacting with. And so for more resources, I know that you could probably go to beefitswhatsfordinner.com, find some nutrition facts on meat in the diet. Gents, do you have any last parting words on maybe additional resources that folks could check out this whole idea of the meat factor, or is this pretty new stuff?
Yeah, it is certainly new stuff. I mean, you know, I don't want to say that we figured this stuff out. Far from. When we're doing metabolomics work, I'm pretty sure we're just scratching the tip of the iceberg. I'm convinced of that. So when someone says like, "Oh, we can replicate a food," then I'm like, well, I don't think we understand enough about foods to really do that. But okay, that's a whole different story. But yes, we don't fully understand it yet. At the moment, it's coming more and more in scientific literature where we talk about those things, more papers coming out on the whole food matrix. Like I said, that recent review article about the meat factor. We see that things are happening. We see that the sum of a food is more than individual components, but we don't fully understand why that is the case yet. And maybe we won't ever fully understand it in our lifetime because it's so incredibly complex. But so that's really where, yeah, thinking of it is that it depends on if your listeners are interested in reading scientific literature, but you can definitely find it in the scientific literature over the last few years. So PubMed or Google Scholar. And I know Jerrad and I probably talk about this in our work. So maybe some of our papers that we've written, but also just, if you Google meat matrix or meat factor, I'm sure you'll find some interesting articles in the scientific literature that are telling us that something's going on. We just don't know what's going on exactly.
Well, and that's good enough answer in that for our listeners, stay tuned, right? There's more to come. There's a lot more for us to understand. I still strongly, very much believe that meat is very important in a healthy diet. For most people, there's always going to be an exception. It's a spectrum. And as Dr. Van Vliet has mentioned too, that some may need more, some may need less, depending on their background nutrients that they're taking in, and depending on their point in their life cycle. Are you a growing adolescent? Are you a mature adult? Or are you one more in our older population that may need additional help in certain areas? And meat, I strongly believe, and it sounds like that there's some evidence that it is a great part of a well-balanced diet. And so, gents, thank you so much for joining us today. I really appreciate your time. I know you're very busy folks, but keep up the good work. And if there's ever a chance for us to visit again about this topic, I think it's fascinating, especially as we continue to learn more about it. The population needs to know. They need to know that meat is an important part of the diet. So thanks.